Let's start our discussion over objects in JavaScript, and pretty much the same way what we did with arrays. We will discuss about what objects are and what are some of the most important inbuilt methods for objects in JavaScript. So let us get started with iDigitalPreneur. Now I have my REPL open up and I'm going to create an object and we'll see what are the different aspects and properties and characteristics of an object. So to create an object in JavaScript, you simply declare the name of the variable. So you can use either let or const. So I'm going to use a const and I'm going to name my object obj. And the way you represent an object is via a pair of curly braces. Now, if you remember from the previous videos, a curly braces did actually create a scope in functions, if else statements, and for loops. But when we talk about the curly braces of an object, it does not actually create a scope. Rather, it's just a syntactical notion that the object is represented by a pair of curly braces. Now, an object in its very naive definition is a collection of similarly related characteristics and properties and methods which kind of denote a single entity. So if you remember from the data types example in JavaScript, we took the example of us as an object so that we had a name, we had a gender, we had an occupation, we had different properties associated to us. And if we wanted to represent those properties, we could use an object to denote that. So let's say I want to denote myself. I'm going to say const Mohit. So this is me, and my name is essentially Mohit, and I'm going to put that as a string. And the next property that I'm going to add in for myself is, let's say, my age. And let's say I want to add in another of my property that is an occupation. So I'm going to say something like this. Now you will see how I'm inserting these characteristics and properties inside of the object. Each of these rows is basically called a record, and a record is essentially a combination of a key value pair. So anything which comes at the left hand side of this semicolon, that is considered to be a key, and then we have an associated value to the key which we have defined. Pretty much the same way we have a name and we have defined the value to be Mohit. Now you can define any key name you can. The key name is arbitrary, and for the value it could be any of the primitive data types or non-primitive data types that we have seen so far. So let us say that I wish to create a list of my family members as well. So maybe I'll say family, and this could be any of the data types whatsoever. So for a list I could make this as an array, and inside of this array I could have all of my like family members present here, so something like this. And if I have anything apart from this, I can nest together arrays and objects inside of it. So I can create a very deeply nested object in JavaScript. Now, the way to access the values, because mostly what you want is to access these individual values. So you're most concerned with accessing the values rather than accessing the keys. So in order to access a certain value, we access it via its respective key name. Now, what do I mean by this is, let's say I want to access the occupation of myself. So I'm going to say console.log, and then I can do it via two ways. There is a dot operator and there is a bracket notation, pretty much like there is in array. So I'll start off with the dot operator. In order to access a certain value, I'm going to say Mohit dot, and then I can access the values via the key names because I want to access the occupation. So I'm going to say Mohit dot occupation. If I run this code, I'm going to get the output of lead front-end engineer because that is the value associated to this particular key. So anytime you're accessing a key, you basically access it via the key name. Now, let us say that I wish to access the same uh, I wish to access the same value, I'm going to use bracket notation, and these two are interchangeably used, but most of the times you will be using the dot operator because that is a much more intuitive way of accessing properties and values inside of an object. So in order to do this, I can do something like this, and I'm going to say occupation, and let's run this particular code and see if this works. So now you'll see that even with this particular notation, I am able to get the answer of lead front-end engineer. Now, what's the difference between these two ways of accessing values inside of an object? Now, the dot operator considers that the key name that you are accessing is actually present inside of the object. That means it cannot be dynamic in nature, and that is one of the disadvantages of using a dot operator, is that if you have a scenario in which you have a dynamic key name, that means the key name is being defined by an external variable or an external factor. In that case, you won't be able to use the dot operator because the dot operator requires the key names to be static and they should be available inside of the object itself. In contrast to that, if I'm using the bracket notation, because I am using a string here, and string actually denotes that there is in fact a key name by the name of occupation inside of Mohit. Let's say this key name which I have accessed, it was dynamic. So what I'm going to do is I'm going to create a variable. Let's say its name is key name, and I named it to be, let's say, family. Now, let's say I wanted to use this variable as a key name. I could not use it inside of my dot operator. So if I did this, and if I ran this, you will see that it gives me undefined even though the variable has a value by the name of family. So this is the disadvantage of using a dot operator. But if I were to use this with a bracket notation, so instead of using this as a string, pretty much like this, I can use a dynamic key name like this. And now once I run this, it will automatically calculate the variable name, the value associated to this variable, and it will resolve it within the object to give me the final value inside of the object. So these are the two advantages and disadvantages of the dot operator and the bracket notation. Mostly you will be using the dot operator, but in certain scenarios in which the key name is not determined or not predetermined, you would go ahead and use a bracket notation to kind of simplify things and make things easier for you. Now, the next thing that we are going to discuss for an object is the nesting part. So let us say that I create another of my key name. So I'm going to say, let's say, address. And this address can potentially be another object. So I'm now nesting objects inside of object. And each of these objects can be, let's say, the city. I have defined the city, and this is city. And let's say the pin code, right? The pin code could be any number whatsoever, right? Something like this. And now let's say I wanted to access the city in which I reside. So for my console.log, I am going to do something like this. Now I can use the dot operator and I can chain together multiple key names, or I can use the bracket notation and chain together multiple key names to achieve my output. Now, if I wanted to access the city, I could do mohit.address. Now, if I do mohit.address, I am going to get this object back because this is the value associated to the address key, but I'm interested in the city. So now I will do dot city because this dot city is present inside of the address. And now if I run this, I'll get the answer of New Delhi because that is present inside of my address object. So you can have any level of nesting inside of your object, and you can use the dot operator and the bracket notation to kind of access the values present in deeply nested objects. Now, most of the times, to kind of contradict with the fact that some of the key names might be undefined and you are kind of dynamically winging through the names of the key names, there is a question mark operator which you can put after the name of every key name so that JavaScript knows that it checks for a particular key name inside of the object. By any sheer chance, if this particular key name is undefined or not present, JavaScript won't throw you an error, rather it will give you undefined. And this is a good practice, but there are of course newer ways to kind of tackle it. But this is something called a question mark, like key name chaining, which we will discuss when we start off with the React module. But this is a great way to find out if a certain key is available inside of the object or not. So that pretty much brings us to the end of the discussion over what objects are and how we can access certain properties and methods inside of my object. One last thing which I would like to mention is that the key name could be any name whatsoever. There is no rule for actually putting in the key name, but your values can be any of the data types available in JavaScript, and that also means that some of the values could potentially be a function. So let us say I write that I will say hello. Say hello could potentially be a function. So I'm going to write it something like this. And inside of my function, I could just write in hello, right? And now let's say I wanted to execute this function. So I will say Mohit dot say hello. And remember how we used to execute a function? We write a pair of brackets after the function name. And now once I run this, I am going to get hello, which is my console.log inside of the function. So it could be any of the data types whatsoever, and you can nest together multiple data types to create different sorts of values in objects. Now, the first property of the object, or this first method that we're going to look at, which is present inside of JavaScript, is something called object.freeze and object.seal. Now, object.freeze and object.seal are two inbuilt methods inside of my JavaScript specification. Although they kind of function the same way, yet there are some stark differences between them. Now, let's say I create an object. I'm going to create an object and I'm just going to keep things simple here. So I'm creating a key name by the value of A, give it a value of 1. Then there is a key name by B. I'm going to create a dummy object like this. And let's say something of this sort. Now I have created this object. Now I can go ahead and do object. Now you will see that I'm using the object with a capital O because uh, this is an inbuilt specification inside of the JavaScript specification. Whenever you're trying to access any of the object methods, you use the object with a capital O, and inside of this object we have all of the inbuilt methods. This is something which is closely related to prototypal inheritance. Now that is something which is way theoretical, and I'm not going to go into the details of it. But whenever you're trying to access any of the properties of objects whatsoever, you have to use the object with a capital O. So first of all, we'll see object.freeze, and object.freeze, inside of object.freeze, I can pass in the object which I want to freeze. Now, what does freeze do? And I will also add an object.seal, and I will pass in the same object. Now, what does object.freeze do is that it freezes the object, right? So that there is no modification, and it basically makes your object immutable. Now, what do I mean by this is, now that I have frozen the object, if I wanted to change a certain property, and I can directly do it, I can do something like object.a is equal to 22, right? For example, if this object.freeze was not present and I did something like this, obj.a is equal to 22, and now if I did console.log of obj, which is my object, right? Then we would see that the value of a has changed from 1 to 22. So this is the default behavior of non-primitive data types like arrays as well as objects, that you can directly alter or mutate the value of something which is present either in arrays on in different indexes or on different key names in objects. But the moment I do object.freeze of obj, now if I try to change or mutate the value of like the key name a, and if I run this, I'm going to see that the value of a still remains to be 1, even though I have mentioned that the value of a should be 22. So freeze is essentially making the object immutable, and you cannot go ahead and do any sort of mutation, any sort of changing of values whatsoever. So let's see another example and see if we can add another key name. So dynamically, JavaScript always calculates if there is a new key name which is defined outside of the boundaries of the object. So if I say obj.d, right, and I named it to be, let's say, Mohit, right, and now if I do console.log of the actual object, if I run this, now you will see even in this case, the new key name is not getting added because I have completely frozen the object. If I remove this and if I ran the code again, then I would see that a key name by the name of D with a value of Mohit was already added in the object. So freeze is a great way to create an immutable object so that no matter any sort of modification or addition towards the object cannot be done. Now let's see the concept of object.c dot freeze works. That means you can it basically makes things immutable, but it is partially immutable. What do I mean by object.seal is, although you can not add new properties or new methods inside of the object, yet the modification of the internal methods and properties and key names are allowed. So if I do obj.a is equal to 22, I'm going to go ahead with the same example, and I'm also going to add in a certain key name by the name of Mohit, right? And let's do a console.log to see what happened once we did object.c. Now, if I ran this code, you will see that the value of a became 22 because internal modification or internal immutation of something which is of a key name, right? These things are allowed in object.seal, although it was not allowed in object.freeze. Yet if I tried to add in a new property inside of the object, that was not allowed, and still my object does not have the reference or any key name by the name of D. So object.seal only differs in the fact that you cannot add external key names and properties and methods, but you can definitely change things inside of the object. This could be useful if you want to create a singular object which cannot be modified by external factors or side effects, yet the internal modification of the object is allowed. So object.seal allows us to do that. Now, the next property that we're going to see is one of the most important properties, and these is called object.keys. Now, object.keys basically returns me an array of all the keys available inside of my object. So I will create an object once again, and I'm going to create the same object which I did, right? And now I am going to do object, and remember object needs to be with a capital O, right? Object.keys, and object.keys I need to pass in the object for which I want to return a list of keys. Because it is returning a list of keys, I can store it inside of another variable, something like this. And if I print these keys and if I run this, I will see that I am going to get a list of all the keys available inside of my object. As you can see, all of these keys are in the form of a string. Now, this is the default behavior because key names cannot be of different data types. That means you cannot do key names to be like this, or an object, or you cannot do key names to be true or something like this. Key names needs to be a variable name, a valid variable name, and the value can be of any data type whatsoever. So whenever I'm doing object.keys, it returns me a list of all the keys or an array of all the keys with each of the key names as a string. Now, this could be useful if you are trying to iterate over the object, and this is something which I wanted to come later on. But an object does not have an order pretty much the same way how we have the concept of order in array. So in array, we have indexes from 0 to n minus 1. But in object, if I'm trying to say that this is the first property and this is the second property, object internally, it does not maintain an order, right? It does not mean that the first key will always be the first key inside of the memory of the object, or the last key is always the last key present inside of the object. And that is why it becomes really difficult if you are trying to iterate over the object to kind of maintain a sequence. Now, using object.keys, we can now run a loop to kind of iterate over the object. And what I mean by this is we can do keys.map, and for each of the maps, I can potentially just go ahead and do console.log, and I will do obj of el. Now, what I mean by this is I'm going to iterate over this array, and for each of the key names, I'm going to insert that key name as the bracket notation of my object. And if I run this now, I'm going to get 1, 2, and 3 in order. So this is a good way if I wanted to iterate over an object using object.keys. There is another way of iterating in JavaScript that is a newer addition to the specification, and that is using the for in method. So you will say for, and then you define the key name. So you can say const key in obj, something like this, or let's make this as let. Now, if I do console.log of key, and if I run this, I'm going to get A, B, and C. Notice the difference in the key here. I'm getting the A, B, and C, but these are not actually strings or anything. These are getting returned in not in an array, but in individual sequences, right? So this is another way if you wanted to iterate over an object, or you can use object.keys, iterate over that array, and for each of the array elements, you can access dynamically using the bracket notation for the individual values. So this is one of the use cases of object.keys. We will move on to the next method in consideration, which is called object.values. Now, object.values is pretty much the same way how object.keys works, but the only difference is that object.values actually returns. So I'll say const values is equal to this, and I'm going to say console.log of values. Now, if I do this, I am going to get a list of all the values present inside of my object. So let's say you wanted a use case in which you wanted a list of all of the different values available inside of the object. Instead of using object.keys, you could use object.values, and the return type or the return data type is pretty much the same. But instead of the key names, we are getting the values of the object. Now, there is one another object method, and that is object.entries. The object.entries is something of a weird sort, so I'll show it to you what I mean by it. I will again reconstruct the object which I did, and now I can say object.entries, and I will pass in the actual object. And because this is returning me something, let's say I will store it inside of my variable. And now I'm going to do a console.log of entries, run this code. So you will see that I am getting an array of arrays. Now, what do I see in this array? That this is a global array. Inside of it, we have 3 arrays like this. And each of these 3 arrays, have the sequence of key and value inside of it. So Object.entries actually returns me an array of arrays with each individual array items holding the key value pair as the first and the last element of the array. Now, there could be potential use cases for object.entries, but mostly you won't be using object.entries to kind of traverse over things. But in certain scenarios where you want access to both of the object.keys and object.values, or the keys and the values at one go, you can use object.entries for your use case. Now, mind you that object.entries, object.keys, and object.values, they have their own performance considerations. So I would highly encourage that you don't overuse these methods, because whenever you use these internal methods, it takes up a lot of computational power for your JavaScript code. And that is why you only use object.keys if and only if you require of something of that sort. So we discussed object.entries, object.keys, and object.values. We also discussed how we can create immutable objects using object.freeze, and how we can seal the object to kind of allow internal modifications but not external modifications using object.seals. Now we will discuss one concept which is very common in objects and a lot of people get it wrong. That is the concept of deep copy versus shallow copy. Now, whenever I'm trying to copy a certain object, or I wish to copy the contents of a certain object from one object to another, basically by default, anytime you're copying the object, it does a shallow copy. Shallow copy is a type of copy in which the nested properties, let's say I again create the object. I have A to be 1, B to be 2, C to be 3, and let's say there is a D, and D is an object where it has Q is Q3, R as 4, and T as 5. Now, when I wish to create a copy, or like a entire copy of this object, let's say I do something like obj2, and this is one of the ways of copying. This is one of the ways of copying objects. We'll see about the spread operator and the rest operator in the next video. But whenever we do a copy of the object, only the first level of nesting is copied, but if we have any other levels of nesting inside of my object, that will not get copied exactly. And this is what we mean by shallow copy. Now, most of the times, or rather I would say 100% of the times, you don't want a shallow copy, you want a deep copy. Now, although before a lot of other specifications, it was really difficult to do a deep copy manually, and we used to take the help of a lot of helper methods and libraries present on the internet. One of them was using Lodash. Now, there is an inbuilt method in which you can create a deep copy of any object, and that is using a method called structured clone. So you can do structured clone and structured clone, and you can pass in the object which you want to copy. And now, instead of the object being copied as shallow, I'm going to get a deep copy of the object, right? And now if I do console.log of obj2, and if I run this, I am going to get the exact object copy like we did for the original object. So most of the times when you wish to copy the contents of one object to another, most of the times, or rather all of the times, you would require it to have a deep copy, and structured clone is an inbuilt JavaScript specification which can help you achieve it. Now it has actually removed a lot of hassle of kind of going through hacks to deep copy a certain object, right? And I would highly encourage that you use the structured clone method in JavaScript to deep copy any of the object instead of using any external library like Lodash to do the deep copy for you. So this kind of brings us to the end of different methods and properties which are actually required for a lot of object manipulations. Of course, there are a lot of properties and there are a lot of methods which are there in the object specification, but the uh, methods and properties that we have discussed today, that will pretty much be 90 to 95% of the use cases of whenever you are managing or handling objects, right? We still have a lot of discussion over JavaScript left. So I will see you all in the next video.